Hey everybody, in this video we are on example 7 over here, and we are going to take it a little further than what we just did in example 6. We are going to see two different scenarios. One where we have the trig inverse of the trig of an angle, this whole thing over here. So the trig of an angle is going to give you as an answer a ratio. If that trig is sine, the ratio is opposite over hypotenuse, etc. Then we're going to do the trig inverse of a ratio, and the answer we will get will be an angle. But it's a little tricky because, well, for one thing, not every ratio works for every trig inverse situation. And the other thing is not every angle that we put in to begin with is going to qualify as an output at the end. So for a little bit more on this, you can go back one or two videos in the playlist and I will go over more detail, but I'm just going to go into these examples here and now. So 0.5, since I'm taking the sine inverse of that, that means that 0.5 is a ratio. That ratio could be thought of as 0.5, it could be thought of as 5 over 10, it could be thought of as 1 over 2, all good. But since it's sine inverse, it's most important we know that it's opposite over hypotenuse. Is this an appropriate ratio? Can the opposite be 1 if the hypotenuse is 2 and so on? So far, it seems fine to me. Now I'm going to pretend that I don't know that this is a unit circle angle. I'm going to pretend I don't know that 0.5 is in the range of sine, and I'm just going to do this out kind of a longer way. So sine inverse of 0.5, I'm going to picture that drawing. My opposite is maybe 5 when my hypotenuse is 10. Maybe I do too much. I use Pythagorean theorem. I find the missing side and I get 5 root 3. And then my angle's over here. Okay, so the sine inverse of 0.5 is equal to some angle theta. Well, where exactly is this angle theta that we speak of? Well, that angle theta is really right here in this triangle. It's going to be something like that. And now I'm being asked to find the sine of that angle. Well, what's the sine? Well, it's opposite over hypotenuse, so it equals 5 over 10 or 1/2 or 0.5. So I get back exactly what I started with. And again, if you know that 0.5 is in the range of sine, then you know you can cross those out. Next example. I'm going to start this one exactly the same way. Since I'm taking the sine inverse of 1.8, then 1.8 is the ratio. How do I change it to a fraction? Well, it's 18 over 10. Or maybe you think of it as 9 over 5. But either way, it's still going to equal the opposite over hypotenuse. Now, do those proportions, 18 over 10 or 9 over 5, do those proportions make sense for an opposite over hypotenuse situation? And the answer is no. I can't even do this one, so there's no solution. We can't even do this example. Okay, the throwaway right from the beginning. All right, number 6 now. Number 6 is similar to the first one that we did. I have the sine inverse of a negative 0.8. So that could be either 8 over 10 or that can be 4 over 5, both of which I would make negative. And if I want to picture that, it's going to be down here in the fourth quadrant because it's between 0 and negative pi over 2. Opposite would be the negative 4. Hypotenuse 5. And if I know my Pythagorean triples, then that's 3. Then my angle is theta right over there. Now, the sine inverse of negative 0.8 is going to be that angle theta, which is actually going to be a negative acute sized but negative angle. And now I want to find the sine of that exact angle. Well, sine is opposite over hypotenuse, and I have a picture. So my opposite, negative 4 over hypotenuse 5. So negative 4 over 5, or really it's negative 0.8. So again, I have another example like number 5 that I could have crossed out right at the beginning. There it is. Next up, negative 2.4. Is negative 2.4 in the range of tangent? The answer is yes, and normally you just can cross out and you get negative 2.4 as your answer. Again, if you don't really understand that, just to visualize. Tan inverse of a negative, if you go back to the heart chart, which is on the screen, I keep kind of referencing that basically, that means the triangle or angle in question is going to be in this general vicinity. Now, negative 2.4 is the ratio, so that's negative, if I make it a fraction, negative 24 over 10, which is negative 12 over 5. And tangent is opposite over adjacent, so negative 12 over 5. And then if it's a triple, well, 5, 12, 13. So here is my picture, and my angle theta is right about there. And now I want to find the tan of the angle theta. Tan of theta. Based on the picture I've drawn, well, it's opposite over adjacent. Or it's negative 2.4, and we're done. All right, a couple more. Cosecant of cosecant inverse, negative 17 over 6. So cosecant of a negative, cosecant inverse of a negative, means that we are looking in quadrant 4, bottom right corner. All right, so my triangle's like this. It is the reciprocal of sine, so 17 will be my hypotenuse, and opposite is 6, but the negative will go with the 6. Ooh, I can't draw there because you guys can't see it. So let's go. Let's erase one of these. Make some space, okay? So we have 17 hypotenuse, opposite is 6, but that will get the negative. So there we go. Not the brightest looking right triangle, sorry. Okay, so from there, could I find the other side? I could, but I don't even need it. So if that's what cosecant inverse is drawing for me, and my angle is somewhere in here, and now I'm going to take the cosecant of said angle. Well, the answer is going to be negative 17 over 6. So there you go. Because unlike sine, the output for cosecant is not between negative 1 and 1 inclusive, but it's outside of negative 1 and 1 also inclusive, including those two numbers. All right, 2 more examples in this set. Next up, we have secant 0.3. So 0.3, which is 3 over 10, is going to be my ratio. And that would be hypotenuse over adjacent, since secant is the reciprocal of cosine. And since that makes no sense, we can just say no solution. And then, last but not least, cotan inverse. Now, cotan and tan, basically anything goes because there's no hypotenuse involved. So now I have 3/10 positive. Cotan inverse of a positive, I could just go over here to quadrant 1. That means adjacent over opposite is 3 and 10. There's my angle. And if I go to take the cotan of that angle, well, I get, nope, what am I writing? I get 3 adjacent over 10, which is the same as 0. Can't fit it there. Let's squeeze it in. Oh, and you couldn't even see my 10. Sorry, guys. That wasn't nice of me. Well, now you see it. Which is the same as 0.3. So there you go. So could I have crossed it out? Yes, because 0.3 is in the range of cotangent. The range of cotangent and cotangent is negative infinity to infinity, right? The graph of tangent has this bit of a shape to it over and over again. And then the graph of cotangent, this one actually has more of this shape when it's positive. And it starts at an asymptote when I graph cotangent. When I graph tangent, we start at a point of inflection, right? But that's the end of these examples. I have some more coming up. So we're going to start even mixing and matching and doing all that good stuff. So that's what's coming up in the next video. So I'm sure you will check it out. But if you're feeling smart and you love it, thumbs it up. Not so much. Thumbs it down. Well, that thumbs down is kind of hidden. I mean, I guess I could pull it up. There you go. So if you're not that happy, thumbs it down. And check out the playlist that's on your screen right now or one of the videos that pops up that might be good for you. And hopefully you found what you're looking for. All right. Adios for now. Bye.